Okay, YouTube, in this video we're going to be exploring the imaginary unit I, and in order to do so we're going to start with a hypothetical situation, but prior to this we've been solving equations, okay, using square roots. So if I had an equation, something like x squared minus 4 equals 0, and I wanted to determine what x values would make this true, we could start by simply adding 4 to both sides. That would be put my 4 over here. We'd say, well, then it follows that x squared equals 4. And so to undo the squared, we'd just take the square root of both sides now that we've isolated the squared thing. We'd say, well, then x must be plus or minus 2. And recall that it's plus or minus 2 because if you were to square a positive 2, 2 times 2 you get 4. But if you were also to take negative 2 times itself, so negative 2 times negative 2, you'd also get 4. Okay. In this video we want to confront, well, what would happen if we had an equation such that it was like x squared plus 4 is equal to, say, 0. And the first thing I want to recognize is this. We're saying we're taking a number times itself, that is x squared, and we're adding it to 4 and we get 0. And really what I want us to recognize is that this number right here, the only number you could add to a positive 4 to get this to all be 0 is negative 4. But the question then becomes, well, what could you take times itself to get a negative? And then that's kind of the interesting question of this video. So to try to solve this guy, we'd also subtract this 4 over to the other side. Well, we would in this instance subtract, not add like we did in the last one. But then we'd take the square root just like we did prior to this previously. We'd say, well, then x equals plus or minus the square root of negative 4. But the thing that's pretty profound about this is I'm asking, hey, what could we take times itself to get a negative 4? And you need to recognize that if you were to take a negative 2 times a negative 2, you'd still get positive 4. And if you were to take a positive 2 times a positive 2, you'd get 4. The bottom line is there's no number that exists that you could take times itself to get a negative 4. And so this right here, we would say prior to this video, we'd say has no solutions. There's no such thing as taking the square root of a negative until now, okay? So here's what we're going to do. Using the properties of exponents, what we're going to do is we're going to take this square root of 4, which is this, square root of negative 4. We're going to rewrite it this way. We're going to say it's the same thing as the square root of negative 1 times a positive 4, which is the same thing as the square root of negative 1 times the square root of 4. Thing here is this, we know the square root of 4. Square root of 4 is plus or minus 2. So we'd say this would be square root of negative 1 times the plus or minus 2. So we'd say plus or minus 2 times the square root of negative 1. It's just that this part right here, we're going to give it a name. We're going to refer to this as the imaginary unit I. And so let's meet me up here in the top left of this canvas, but it says the imaginary unit I is defined as follows. We say I is simply equal to the square root of negative 1. If anybody ever asks you what I is, you say, well, it's a number, okay, and that number is the square root of negative 1. But the consequence of I being equal to the square root of negative 1 is this. If I equals the square root of negative 1, let's consider that if we were to square I, square it. I could also square the right side of this equation, then I would get this. Well, then I squared would be equal to the square root of negative 1 squared, and as we know, if you square a square root, you just get what's in the inside, this. So the profound thing about I is, it is the only number on the planet that when you square it, you get a negative output, okay? So here's the deal. I equals the square root of negative 1, and we refer to I squared as being equal to negative 1. So I say the imaginary unit here, I, can be used to write the square root of any negative number. So the properties we're going to play upon are these. So let's take a look at number 1 here. We say if R is some positive real number, then if we were to take the square root of negative r, we would just get I times the square root of positive r. And this is really, really important. Basically, what we're saying is this. If you were to take the square root of negative a number, you can make this square root positive again on the inside. You just have to put an I out front. And the reason why is we'll take a detour here because this can always be rewritten as negative 1 times that number, which, as we did prior to this, we split it up into negative 1 square root of that times the square root of positive r. And so we get this. This is I. Of course, the square root of negative 1 is equal to I times the square root of positive r. So the bottom line is this. You can rewrite any negative square root of a negative. Like, for example, I write the square root of negative 5 is equal to just I times the square root of positive 5. The rule of thumb is this. If anybody ever hands you square root of a negative, you can just rewrite it with an I out front and then make what's on the inside positive. Those are the rules, okay? So we say this is an imaginary unit here, and it's equal to the square root of negative 1. Simple as that. Going back to this example here, the square root of negative 5. We say, well, the square root of negative 5, using the property I've just listed here, can be rewritten as I times the square root of positive 5. So we say I times the square root of positive 5. What if we were to take this and square it back out? What would we end up with? Okay, so if we were to take this, I times the square root of 5, and square it we would get the first thing squared here, we'd get I squared. And we get the square root of 5 squared, which is just 5. But the thing here is this, I squared, as per what we've written up here in the top left, we need to recognize is negative 1. It is the square root of negative 1 squared. So we'd get this, negative 5. So the profound thing again is this, I squared exists so that when you square it, you get a negative output. Okay. So the reason why we're going to be using I in the first place is to solve equations like you see up here, and we'll finish this video. But we said if I had this equation here, it's a quadratic equation. I notice there are only x squareds on it. That is, I don't have an x squared and an x to the first term. This means that we can get the squared thing by itself, this thing by itself, and then go ahead and take the square root of both sides. So this means we'll start by subtracting 10 from both sides, simply put, and we get this, 3x squared is equal to negative 36. So now we can divide both sides by 3. We get negative 36 divided by 3 is negative 12. So now we'll take the square root of both sides. We got the square thing by itself. Let's take the square root. So we get x equals the square root of negative 12. So I notice there's a negative in here. And prior to this, we say, well, there are no real numbers that cause this to happen. You couldn't square something and get a negative 12. So what we'll do is this. We will make this what's on the inside positive just by putting a plus or minus I out front. And as a matter of fact, we can simplify this 12 right here. That's the same thing as 4 times 3. And we know the square root of 4 to be 2. So this 2 comes out front here and gets multiplied by whatever was already out front. So we get this plus or minus 2i radical 3. Before we kind of finish this video, I want to recognize one thing. If we had had x equals plus or minus radical 12, this would have been x equals plus or minus radical 4 times 3. And we know the square root of 4 to be 2, so we put our 2 out front. We get x equals plus or minus 2 radical 3. So the only difference here between these two answers is simply this. When you're dealing with a negative on the inside of the square root, you're going to get identical outputs, 2 radical 3, 2 radical 3. It's just that there's an I in front of this one. So the whole gist of this video is, hey, I is equal to the square root of negative 1. I equals the square root of negative 1. I squared, well, that equals just negative 1. And bottom line is, if you ever have a negative inside your radical, as you do here, just put an I out front and make what's in there positive and deal with it as you normally do. Okay, cheers.